All right, part B is asking us to find all intercepts of this graph. So to find, let's do one at a time. Let's find y-intercept first. To find y-intercept, plug in x equals 0. Because to be on the y-axis, you see, to be on this line right there, you cannot go to the right or left. You have to be at x value of 0, right? You have to be at the x of 0. So that's why we're going to plug in x equals 0 to find any y-intercept. So here I go. Y equals, on top of the fraction, I will do 0 plus 4, right? And in the denominator, I'll do 0 squared minus 5 times 0 minus 36. If we simplify this, we get 4 over, let's see what this is, 0 minus 0 minus 36. So that is 4 over negative 36. If we simplify this, that is 1 over 9. So y-intercept is at 0, negative 1/9. So we found the y-intercept. Now let's find the x-intercept. To find, and we may have more than just one this time, to find x-intercepts, maybe multiple, we're going to plug in y equals 0. See, there's no y here, but you know, f of x, that's the y value. So what we will do is we will set this entire fraction equal to 0. So take a look. We're going to say 0 equals this entire fraction. 0 equals x plus 4 over x squared minus 5x minus 36. Now, this is going to be a little bit tricky, okay? Because a fraction is 0 when the numerator is 0. But you guys remember in the first video how when we factored and simplified this? Okay, I'm gonna get this one, okay? I'll copy this. Now this is from that very first video on this page. You see, when we factor this, we got this fraction all the way on the right, this right there. And I'm wondering, can that fraction ever be equal to 0? Okay, because you know a fraction is equal to 0 when the numerator is 0, right? I'm gonna solve both of them so that because I want to show you. But if I set that orange fraction equal to 0, we're gonna have a problem. Take a look, okay? To get rid of this fraction format, I can multiply both sides by x minus 9, right? I can multiply both sides by x minus 9. So what will happen to this x minus 9 on this side? That cancels out. Okay, now watch this. We have 1 left on the right side, right? Come straight down. But what is anything times 0? Is 0 equal to 1? No, it's not. So this orange work right there just told me that this function will never be equal to 0. The function value will never be equal to 0. Well, I would have missed that if I use this and just set 0 equals x plus 4 and get x equals negative 4, because even though x equals negative 4 is the numerator 0, it also makes the denominator 0. So remember what happened at x equals negative 4? We identified that is where the whole of this graph is. So super interesting, right? We thought we could just solve for the x value that makes the entire fraction 0, but if you weren't being careful, we would have missed it, because in a simplified form it will never be equal to 0. So what do we say about the x-intercept? Does it have any x-intercept? No x-intercept, because the only candidate that could have happened was at x equals negative 4. But this graph has a hole at x equals negative 4, because x equals negative 4 is not only the numerator 0, but also the number that makes the denominator 0. So you have to say this graph has no x-intercept. And if you want to confirm that, okay, we can go over here and see is this graph touching the x-axis anywhere? Now, to the right end, it doesn't, right? Because it gets infinitely close to the x-axis, but it just never touches it. Now, over here, okay, that's a little tricky. I'm trying to zoom in over here. Try to zoom in. See, over here we have this -4 and that whole value right there, but it's not really on the x-axis. In fact, I remember that this function has a horizontal asymptote at y equals 0, so it doesn't really have any x-intercept. So that's what we got for part B. Okay, I'm going to stop this video because I want to start a new one talking about the increasing and decreasing interval.